All right, so we've got this huge stack of info here all about Terraform. Seems like everyone in DevOps is talking about it these days. What's the big deal, and how can it actually help someone like you manage their infrastructure?
It's definitely a big deal, way more than just hype. I think Terraform is like a fundamental shift, in how we approach infrastructure. It's really the poster child for this whole concept of infrastructure as code, which people usually shorten to IaC. So instead of manually clicking around in a web console to set up all your servers and networks, you actually write code to define what you want, and then Terraform goes and makes it happen.
So is it kind of like a blueprint, but instead of being for a building, it's for like your whole IT setup?
That's a great analogy. And just like a good blueprint, make sure that you've thought of every little detail. Terraform helps prevent errors and inconsistencies when you're setting up your infrastructure. One of the biggest benefits is repeatability. Let's say you need to set up the same environment a bunch of times for different projects or different teams. With Terraform, you can just reuse your code. You just saved yourself potentially hours of tedious manual work.
That does sound pretty appealing, especially when you're dealing with really complex infrastructure. Are there other advantages too?
Absolutely. Another key benefit is preventing something called configuration drift. Have you ever run into a situation where, like, your development environment slowly starts to become different from your production environment, and then you have all these weird issues popping up?
Oh, yeah, all the time. It's like trying to track down a ghost in the machine.
Exactly. Terraform helps keep all your environments in sync. That way, you have consistency, and it reduces the risk of those frustrating works on my machine situations.
Interesting. So how does Terraform actually pull this off? What's the magic behind the curtain?
Well, the magic is in the way Terraform uses a declarative language. Instead of telling the computer how to do something step by step, you just describe the end state you want. It's like giving someone directions by describing the destination instead of telling them every single turn to take.
So I just tell Terraform what I want my infrastructure to look like, and it figures out how to get there.
Exactly. That not only simplifies things a lot when you're defining your infrastructure, but it also makes your code much more readable and easier to maintain.
Okay, I'm starting to see why people are so excited about this. But how does Terraform know how to talk to all these different cloud providers and platforms? Because each one has its own way of doing things, right?
Right, and that's where providers come in. They're like plugins that allow Terraform to interact with specific platforms, like AWS, Google Cloud, Azure, and even things like Kubernetes or even Mastodon. Each provider exposes a set of resources, which are like the building blocks of your infrastructure.
So if I wanted to create a virtual machine on AWS, I would use a resource provided by the AWS provider.
Precisely. And for example, the OS instance resource lets you spin up a server on AWS. Each resource has a set of arguments that allow you to customize its configuration.
This is starting to make a lot of sense.
Yeah.
But how does Terraform keep track of all these resources and all the changes it makes to my infrastructure?
It uses something called state. Think of it as like a snapshot of your infrastructure that Terraform stores in a file. This state file is super important because it lets Terraform understand what's already been created and what needs to be changed.
So it's like Terraform's memory. It remembers what it's done so it doesn't have to start from scratch every time.
Exactly. Without that state file, Terraform wouldn't know what resources it was managing, and that would lead to chaos and errors for sure.
Okay, so we've got declarative language, providers, resources, and state. Those seem to be the core concepts of Terraform. What's next on our journey to Terraform mastery?
Well, now you understand the concepts. The next step is learning how to actually write Terraform code. The language it uses is called HCL, which stands for HashiCorp Configuration Language. Don't worry, it's designed to be pretty human-readable and easy to learn, relatively speaking.
That's good to hear. I'm always intimidated by new programming languages. Can you give me a taste of what HCL looks like? Like, how is it structured?
Absolutely. Imagine you want to create that AWS instance we talked about earlier. In HCL, you would define a block for the OS instance resource, and this block would contain arguments that specify things like the instance type, the operating system image, and all those configuration details.
So a block is kind of like a container that holds all the information about a particular resource, and the arguments are like specific instructions, parameters.
Exactly. HCL is all about defining blocks and arguments to describe your desired infrastructure. It's a very structured and organized way of writing code.
That sounds pretty intuitive, even for someone who doesn't have like a deep coding background.
That's the idea. The goal is to make infrastructure management accessible to a wider range of people.
So let's say we've written our HCL code, we've defined our resources and all the configurations. How do we actually tell Terraform to go ahead and build all this infrastructure for us? Is there like a button we press?
Not quite a button, but we have something even better. The Terraform CLI. It's your command line interface for interacting with Terraform and managing your infrastructure.
Ah, the command line. I've dabbled with it a little bit before. What are some of the key commands we'll be using?
There are a few essential ones that you'll want to get to know. First up, there's Terraform init. This is like setting up your workspace. It downloads the necessary providers and gets everything ready to go.
So it's like gathering your tools before you start building something.
Yeah, exactly. Once you've initialized your workspace, you'll want to run Terraform plan. This command shows you a preview of what Terraform is going to do based on your code. It's like a safety net, so you can review the changes before they're actually applied.
I like that. It's always good to double check before making big changes. So how do we actually tell Terraform to go ahead and build our infrastructure based on the plan?
That's where Terraform apply comes in. This command takes the plan that you've reviewed and makes those changes to your actual infrastructure.
It's showtime. What if we need to undo those changes? Maybe even completely tear down our infrastructure. Is there a command for that?
There is. It's Terraform destroy. It's the command you'd use to remove all the resources that Terraform has created. It's a very powerful command, so use it with caution.
Definitely good to be careful with that one. Are there any other commands that we should know about?
There are two more that are really helpful. There's Terraform FMT, which helps ensure that your code is consistently formatted. That's really important for readability, especially when you're collaborating with others. And then there's Terraform Validate, which checks your code for errors and potential issues before you even run it.
So that's like having a spell checker for your infrastructure code. Okay, so we've got these 6 commands in our toolbox: init, plan, apply, destroy, FMT, and validate. With these, we can control the entire life cycle of our infrastructure, from creation to destruction.
Exactly. These commands are at the core of how you interact with Terraform. Master these, and you'll be well on your way to becoming a Terraform pro.
This is great, but remember earlier when you talked about state management and how Terraform uses that state file to keep track of everything. Can we dive a bit deeper into that?
Sure, state management is critical, especially when you're working in teams or on larger projects. And there are two main approaches: local state and remote state.
What's the difference?
With local state, the state file is stored on your own computer, and that's fine for small personal projects, but can become a real problem when you're collaborating with other people.
I can imagine that leading to conflicts. Like, if everyone has their own copy of the state file, things could get out of sync pretty quickly.
Exactly. That's where remote state comes in. With remote state, the state file is stored in a shared location, maybe like a cloud storage service or a dedicated state management tool. This way, everyone on the team can access the same state file. It ensures consistency, and it really cuts down on conflicts.
So remote state is kind of like having a single source of truth for our infrastructure.
You got it. And remote state also has other benefits like version control and the ability to roll back changes if you need to.
Sounds like remote state is definitely the way to go for any serious Terraform project, especially in a team environment.
I'd agree with that. It just adds a layer of robustness and makes collaborating so much easier, which is essential when you're managing complex infrastructure.
Okay, I think we've covered a lot of ground already. We've gone from these high-level concepts of IaC and Terraform to the nitty-gritty details of HCL syntax and the Terraform CLI.
It's amazing how much we've covered in such a short amount of time, and we're really just getting started.
Exactly. Let's take a quick break, and when we come back, we'll continue our exploration of Terraform and dive a bit deeper into actually writing those basic configurations. Stay tuned. Okay, so we're back and ready to get into some real Terraform code. Before the break, we were talking about how Terraform uses this declarative language called HCL to actually define our infrastructure. Can you walk me through like a really simple example just so I can see how all this comes together in practice?
Yeah, definitely. Let's go back to that example of creating a basic web server on AWS using the instance resource. So, this is the resource that lets us define a virtual machine on AWS.
All right, so how would we actually write the HCL code to create this web server?
You would start by defining a resource block, and you do that using the keyword resource, followed by the resource type, which in this case is instance, and then you give your resource like a unique name. Let's just call it my web server for now.
So it would look something like this: resource instance, my web server,
Yeah.
and then curly braces. And those curly braces represent the block where we're going to add all the configuration details, right?
Exactly. And inside that block, we'll specify all the arguments for our web server. So these arguments define things like the type of instance we want, the operating system image, and any other settings that we might need.
So what are some of like the key arguments that we would need to define for our web server?
One important one is AMI, which stands for Amazon Machine Image. This is what specifies the operating system template we want to use for our server. And we can actually find the appropriate AMI ID from the AWS documentation. Or we can use a data source to fetch it dynamically.
A data source. You mentioned that briefly before the break. Can you remind me what those are for again?
Right. Data sources basically allow us to fetch information from some external source like AWS or other providers, and then use that information in our Terraform code. So in this case, we could use a data source to automatically grab like the latest AMI ID for a specific operating system, which would make sure that we're always using like the most up-to-date image.
Oh, that sounds super useful.
Yeah.
What other arguments would we need for our web server?
Another one that's really essential is instance type. This is what determines the size and the computing power of our server. So AWS offers like a whole variety of different instance types, each with different CPU, memory, and storage capacities. We would just choose the one that best suits the needs of our web application.
Okay, so we've got the operating system image with AMI and the server size with instance type. What else?
We also need to specify all the network settings for our web server. This includes things like the subnet ID, which determines where our server is located within our virtual network, and the security groups, which control the incoming and outgoing traffic to and from our server.
So we're basically defining how our web server connects to the rest of our infrastructure and how it can talk to the outside world.
Exactly. These network settings are super important for security and just making sure that our web server can communicate properly with other services.
Oh, this is starting to come together. So we have our resource block, the instance type, a unique name, and then a bunch of arguments that define all the configuration details. Is that basically all there is to it?
Well, there's one more important concept we need to talk about, and that's variables. Variables let us make our Terraform code way more flexible and reusable. So instead of like hard coding values directly into our resource arguments, we can use variables as placeholders.
Can you give me like a quick example of how that might work in practice?
Sure, let's say we want to deploy our web server to different environments like development, staging, and production. And maybe each of those environments needs like a slightly different instance type. So instead of creating separate Terraform code for each environment, we could use a variable for that instance type argument.
So we would define a variable called instance type, and then we could assign it a different value depending on the environment that we're deploying to.
Exactly. That way, we can reuse the same Terraform code for all our environments just by changing the values of our variables.
That's really powerful. It seems like variables are essential for managing infrastructure at scale.
Oh, absolutely. Variables, along with data sources and other Terraform features, really allow you to create like modular, reusable infrastructure code that can easily adapt to different environments and requirements.
Okay, I'm starting to feel like I'm getting a good grasp on how to write these basic Terraform configurations. What are some of the best practices we should be keeping in mind as we move on to working with, real-world projects?
One that's really important is to keep your code modular and organized. So you want to break down your infrastructure into logical components and actually create separate modules for each of those components.
Wait, modules. You mentioned those before, but we haven't really dug into what those are.
Right. We'll get into modules more in the next part, but for now, just think of them as self-contained units of Terraform code that you can reuse and kind of combine like building blocks.
Okay, so modularity is key. Any other tips?
Another best practice is to use version control for your Terraform code, just like you would with any other software project. This allows you to track changes, collaborate with others, and easily roll back to previous versions if you need to.
Version control is like essential for any serious development work, so it makes sense to apply it to infrastructure code as well.
Totally. And finally, don't be afraid to experiment and tap into the huge Terraform community out there. There are tons of resources online, like documentation, tutorials, and open source modules that you can use.
Yeah, I'm definitely looking forward to diving into that community, to seeing what other people have built. But before we go too far down that rabbit hole, let's come back to state management and talk more about it, especially in the context of collaboration and security.
Great point. We talked about local versus remote state before, but let's dig a little deeper into why remote state is so crucial when you're working on projects with a team.
I'm ready.
So imagine you have a team of developers who are all working on the same infrastructure project. If everyone's using local state, each developer is going to have their own copy of that state file on their own computer.
Right, and as we said before, that just sounds like a recipe for conflicts and a lot of confusion.
Exactly. If two developers make changes to the same resource at the same time, Their state files are going to be different, and Terraform is not going to know which changes it should actually apply. And that's when you start to see errors, inconsistencies, and a whole bunch of headaches.
So remote state solves this problem by providing a single centralized location for that state file.
Exactly. With remote state, everyone on the team is working from the same state file, so all the changes are applied consistently, and it really helps to avoid those conflicts.
Makes sense. But where exactly is that remote state file stored?
There are a few different options, but the most common ones are cloud storage services like AWS S3, Azure Blob Storage, or Google Cloud Storage. You can also use some specialized state management tools like HashiCorp Console or Terraform Cloud.
So we're basically storing our state file in a shared location that everyone on the team can access.
Exactly. And that not only makes collaboration a lot easier, but it also improves security. Because those remote state backends usually offer encryption and access control mechanisms to protect your state file from unauthorized access.
Security is so important when we're talking about infrastructure, so it's good to know that remote state backends have got us covered.
For sure. Remote state is like a fundamental best practice for any serious Terraform project, especially when you're working in a team.
Okay, I think I've got a pretty good grasp of state management now. We've covered local versus remote, why remote state is so important, and some of the options out there. I'm excited to learn more about these modules and see how we can build even more complex and reusable infrastructure with Terraform.
Yeah, me too. Modules are definitely a game changer.
Okay, so we've learned a ton about Terraform already in this deep dive. We've gone from those core concepts of infrastructure as code to the details of HCL and state management. And I'm really excited to kind of unlock that next level of Terraform mastery. And you mentioned these things called modules before. What exactly are they and how do they fit into all of this?
Modules are honestly one of the most powerful features of Terraform. They let you encapsulate and reuse your infrastructure code, so it's easier to manage and it's definitely more scalable.
So is it like taking those basic building blocks we were talking about and then creating prefabricated structures with them?
That's a great analogy. Instead of writing the same code over and over again for common infrastructure patterns, you can create a module just once and then reuse it across lots of different projects or environments.
That sounds incredibly efficient.
Hmm.
Can you give me a real-world example of how these modules work in practice?
Sure. Let's go back to our web server example. So instead of defining all the resources and settings directly in our main Terraform code, we could create a separate module just for web servers.
So this module would have all the HCL code we need to create a web server. That includes the auth instance resource, the network settings, and any other configurations that are relevant.
Exactly. And the best part is that modules can be as simple or complex as you need. You could have a module for a single server, a module for a whole database cluster, or even a module for a multi-tier application.
Okay, I'm starting to see how powerful this could be. But how do we actually create and use these modules in Terraform?
Creating a module is surprisingly simple. You just create a new directory and put your Terraform code in it. Inside that directory, you define all the resources, the variables, and the outputs for your module.
Variables and outputs. We talked about variables before, but what are these outputs?
So outputs let your module expose certain values or data to other parts of your Terraform code. So, for example, your web server module could have an output for the public IP address of the server, and then you could use that IP address in other modules or resources that need to connect to that web server.
So it's like setting up a way for different parts of our infrastructure code to talk to each other.
Precisely. Outputs make it possible to build really complex interconnected systems using modules as those core building blocks.
This is really cool. But what about using modules that we didn't create ourselves? Is there a way to leverage pre-built modules from, the Terraform community?
Absolutely. There's a huge ecosystem of publicly available modules that you can use. The Terraform registry is a great place to start. You can find modules for all kinds of common infrastructure patterns and services.
So I could potentially find a module for things like a load balancer, a database, a Kubernetes cluster, really any common infrastructure component.
Yeah, most likely. And the great thing is that a lot of these modules have been written and tested by people with tons of Terraform experience, which saves you so much time and effort.
Wow, it seems like modules really unlock the true potential of Terraform for building and managing infrastructure, especially at a larger scale.
For sure. With modules, you can break down even the most complex infrastructure into these manageable pieces, and you can reuse your code and also tap into the knowledge of the entire Terraform community. it's a win-win.
I think we've covered pretty much everything I wanted to know about Terraform today. We started with the basic concepts, then we went into the details of actually writing configurations and using modules. I feel like I have a solid foundation now and understand how this tool can make managing infrastructure so much easier.
It's been great talking about this with you. Remember, Terraform is a powerful tool with a huge and really supportive community behind it. So don't be afraid to experiment, try out different things, and keep learning. There's always something new to discover.
I'm excited to keep learning about Terraform and see how I can use it for my own projects. Thanks for sharing your expertise with me.
Of course, anytime. Happy terraforming.
And to all of you listening, thanks for joining us for this deep dive into the world of Terraform. We hope you've learned some new things and found this valuable. Until next time, keep exploring and keep on learning.